Hello everyone, myself Sakshi Bhagel and I'm here with my team members Rijuta and Joshna. Today we'll be presenting a mini project on the topic of digital multiplexer with virtual memory and circular cubes. We hope you would find it innovative and interesting. So now let us see the introduction part of this topic. This project helps us to implement a digital multiplexer to manage some multiple input signals. It uses a virtual memory mechanism for memory management and stimulation. And this integration is inspired by how operating system management and data flow between the CPU, memory, and other devices. And this project can help you to understand the practical application of these fundamental topics in the computer system. So now let us understand about the functions of each part. Let us start with the digital multiplexer. The definition of the digital multiplexer is a multiplexer is a combinational logic circuit that takes multiple input signals and based on a control signals or a select lines output one of those input to the output line. And the function of the multiplexer is often referred to as the data selection in a digital electronics. So now let us understand the working principle of the multiplexer. The control signals, the multiplexer uses a binary control signals or the select lines to determine which input to pass to the output. So now let us understand this with the help of an example. So for an example, in a 4 is to 1 multiplexer, 4 input and 1 output. So there are two control lines which can represent four different types of binary values. The selected input is forwarded to the output line. So now let us understand about the application of a digital multiplexer. Data communication system. Multiplexers are used in telecommunication to allow multiple signals to share a single communication lines. ALU operations. In processor, a multiplexer can choose between different operations like add, subtract, etc. Memory access used to select a specific memory location. Now let us see the key characteristics of a digital multiplexer. First, it reduces the number of communication lines. Second, operates based on the binary control signals. And third is the common configurations of a digital multiplexers are 2 ratio 1, 4 is to 1, 8 ratio 1, 16 ratio 1.
Hi guys, my name is Rijuta. I will be continuing from the functions of each part. So second one is the virtual memory. So a virtual memory, it is a memory management technique that allows a computer to compensate for shortages of physical memory, that is the RAM, and by temporarily transferring the data from the RAM to the disk storage. It also creates the illusion of a large contiguous block of memory for the program, regardless of the actual physical memory size. So, how does the virtual memory work? First is the swapping. So, when the RAM it is full, inactive, or it is less frequently used data in the RAM, it is being moved to a secondary storage called the disk. It is being moved in form of pages. So this process is known as paging or swapping. Next is the address mapping. Virtual memory uses a mapping mechanism to convert the virtual addresses into physical addresses. This is done to a page table. Next is the benefits of virtual memory. So it is efficient memory usage. It allows more programs to run simultaneously, utilizing the disk space as an extension of the RAM. Isolation. Each program gets its own virtual space, preventing interference between the programs. Increased multitasking. It enables the running applications that require more memory than physically available. So the challenges faced are the performance overhead. Swapping data between the RAM and disk can cause delays, especially if excessive swapping occurs. Disk wear, heavy swapping can reduce the lifespan of the SSDs. So applications whereas virtual memory used are like they are used in operating systems. It is a core feature of modern operating systems like Windows, Linux, or Mac. Then, in large applications, it is used in high memory demand applications such as gaming, video editing, and scientific simulations. Next, we have a circular queue. So, a circular queue, it is a linear data structure where the last position it is being connected to the first positions, forming a circle-like structure. It operates in first in, first out manner. That is a FIFO manner. So, how does it work? Circular queue, unlike a regular queue, it efficiently reuses the empty spaces left by the dequeued elements. So there are front and rear pointers. So in the front, they are the pointers like in the first element of the queue. Rear are the pointers to the last element of the queue. So when the rear pointers reach to the end of the queue, a new element is added and it wraps around the front queue. So overflow condition, it occurs when the queue is full, even though there may be empty slots. Underflow condition, it occurs when attempting to dequeue an empty queue. So advantages of circular queue, it is efficient memory storage. It utilizes the space efficiently by reusing the vacant slots. Constant time operations. NQ and DQ operations take time. So applications, they are being used in buffer management. Circular queues are used in buffering data for tasks like input output operations, streaming, and real time systems. CPU scheduling. Circular queues are used in operating systems for round robin CPU scheduling. Networking, it is used in routers and switches for packet buffering. Limitations, it requires careful pointer management to avoid logical errors. It has fixed size that may require for resizing for a larger data assets. Next, we have the code which is being presented by Jyotsna. Thank you.
Hello everyone, I'm Jyotsna. So from now on, I will be continuing this video by explaining the code on digital multiplexer with virtual memory and circular queue. So here is the code. Here, the RAM array stores data temporarily. Its size is limited as we have defined RAM size as 3, stimulating a small memory. If RAM is full, the oldest data is swapped out of the secondary memory, that is disk. So the secondary memory stores data that is swapped out of RAM when RAM becomes full. Disk is dynamically allocated using realloc, allowing it to expand as needed. So basically the main purpose of multiplexer is to select a data input based on the control signal. The function ensures the control signal is within valid bounds and returns the selected input. Here we have used a circular queue that implements a fixed size queue using an array to track recent inputs. If the queue is full, it overrides the oldest data. New data is enqueued at the rear, and old data is dequeued from the front. So here we have given inputs which are stored in an array 100, 200, 300, 400 and 500. A control signal I modulus num inputs selects data using the multiplexer. The selected data is added to both the virtual memory, that is RAM and disk, and the circular queue. After each addition, the current states of RAM, disk, and the queue are displayed. So here we have used few functions. These are add to memory that adds data to RAM or swaps out of the oldest data to disk if RAM is full. Display memory which displays the current contents of RAM and disk. NQ adds data to the circular queue overwriting old data if the queue is full. Display queue displays the contents of the circular queue. So let's see how the code works. So here is the output for the code that I have just explained. So here we have taken the first input as 100. The data is added to RAM as space is still available and no data is swapped yet to disk. Data is again added to queue also. And the second iteration, we have selected the input as 200. So the data is added to RAM as space is still available and disk is still empty. 200 is added to queue. And the third iteration where we have taken input as 300, data is again added to RAM as space is still available and disk is still empty. 300 is added to queue. Now we have selected the input as 400. As we have given the RAM size as 3, so now the RAM size is full and the oldest data 100 is swapped to disk and 400 is added to RAM. So now the disk contains the swapped out data 100 and 400 is added to queue again. And now the fifth iteration where the selected input is 500. Still RAM is full, so the oldest data again 200 is swapped to disk and 500 is added to RAM. So now the disk contains the swapped out data, those are 100 and 200. And also 500 is added to queue, overwriting the oldest data 100 as the queue is full, as we have mentioned in the code that queue size is 4. So the queue has the values 200, 300, 400 and 500. So this is an implementation that demonstrates the concepts of virtual memory, data queues and dynamic memory management. So finally coming to the conclusion of today's video, this mini project gives you a practical understanding of data flow management using digital multiplexer logic, memory management using virtual memory principles, efficient data processing using a circular queue.